In this segment we are going to talk about functional dependency. So in last segment we talked about informal guidelines about database design. In this segment we are going to talk about formal tool and formal guideline for analysis of relational schema. So functional dependency will enable us to detect and describe some of the above mentioned problem in some precise term or in a formal way. So we'll talk about theory of functional dependency first. So what is functional dependency? Functional dependency is a constraint between two set of attributes from the database. So the formal definition looks like that. A functional dependency, we determine a functional dependency between two set of attribute x to y. Okay, so x is a set of attribute and y can be also a set of attribute. Okay, and functional dependency is a constant between these two set of attribute, and we read it like that: y is functionally dependent on x. So this functional dependency says that if we have a functional dependency like that, x to y, or y is functional dependence on x, then this constraint says that for any two tuples t1 and t2 in R is the relation state, if they have t1x equals to t2x, means two tuple has the same value for x attribute, okay, they must have t1y equals to ty, means they must have same value for y attribute. Okay, means for any two tuple, okay, if the x value is same, if x value is y, okay, I'm sorry, if the x value is same, let's say x value is 1 for this two tuple, and then y value will be also same. Let's say for this tuple y is a, and in another tuple if x value is same as like that, y value also must same like that. Okay, so if x value is same, y value must be same. All right, we say that y is functionally dependent on x, okay, or x functionally determines the value of y. All right, so this is a constraint, this is a specific constraint based on a two set of attribute. All right, and these two set of attribute will be actually a subset of attribute from a specific relation R. All right, so let's see an example. Let's see, we have this table employee project. So in this employee project we have SSN and P number primary key, means here actually we are mixing information of employee and project together. So let's see, we have couple of these functional dependency. So the first functional dependency says that determines the value name same for those all. So obviously you can see that Smith record specifically, so SSN is same for these two record, so obviously for these two record the name ename must be same. So obviously intuitively it makes sense, because SSN determines the value of employee name. If SSN is same, their employee name must be same, okay, otherwise it's just a wrong information. All right, so a functional dependency actually it's a like a constraint, okay, that will tell us that a specific attribute value determines the value of other attribute. So in this example, SSN will determine the attribute value of employee name. Okay, so the value of employee's SSN uniquely determines the employee name, or ename is functionally dependent on SSN. All right, so the second functional dependency says that P number determines the value of P name and P location, means that if we have two record where P number is same, okay, for all of this record P name and P location will be also same. Okay, and you can also intuitively find the validity of this information. So if we have if we are going to store all the information of project, P number is the actually unique or primary key attribute for project record. Okay, means for each project that has the p number is same, their p name, p location will be also same. So you can see that p number 1 1, these two record has p number 1 1, their p name and p location must be same. So p name is product X Bellery, and for this record p name must be product X and Bellery. And if this is not same, all right, means p number is same but p name, p location is different, okay, and this functional dependency exists, that means it's a not valid information. Okay, again another functional dependency exists in this table, that SSN p number determines the value of hours. Okay, means for each record of SSN and p number, if same, their total number of hours will be also same. All right, so a functional dependency there actually is a property of relation schema R. It's not actually a particular ligand relation state of R of R. So generally we cannot find the, what does that mean is that we are not going to determine the functional dependency from a relation state. We are going to determine the functional dependency from a relation schema R. For example, if we have like a relation schema, from that relation schema your database designer might specify some of the functional dependency. We might specify that these attributes value will determine other attributes value. Okay, so given a populated relation, we cannot determine which functional dependency hold and which do not. So that is the idea, that from the relation state, means looking at the populated database, we are not going to determine the functional dependency. Rather than we are going to actually identify all the functional dependency from our initial relational schema diagram. Okay, so now we are going to talk about normal form based on primary key. So we are going to first talk about normalization process. So a normalization process is a formal way to analyze the database design. Okay, so what is our approaches for a relational schema design? So our approaches relational schema design, we have talked about different in different chapters. So first we perform a conceptual schema design using a conceptual model, and we talked about them in our chapter 7 and 8. Okay, so having a initial database design requirement or software design requirement, we perform a conceptual schema design using a conceptual model, and then we map conceptual design into a set of relation, and we talked about that in our chapter 7 8 about conceptual model. Then we talk about mapping conceptual design into set of relation in our chapter 9. All right, so then the next step is that we design relations. We can also design relations based on external knowledge derived from existing implementation of files or forms or report. Now when we do this relational schema design, okay, let's see, we have this relational schema design. How do we analyze them, whether to identify the quality of the database design? Okay, that will take a relational schema through a series of tests. All right, and this test will certify whether it satisfies certain normal form. So what is a normal form test? The normal form of a relation refers to the highest normal form condition that it meets, and hence indicates the degree to which it has been normalized. There are a couple of normal forms. We are going to talk about that. There are a couple of normal forms, say first normal form, second normal form, and third normal form. All right, so we're going to take couple of tests, whether we're going to identify whether our database design satisfies a certain normal form. Okay, a normal form test of a relation refers to this highest normal form condition that it meets. Alright, so we're going to identify whether our database design is meeting first normal form, then second normal form, then third normal form test. And then normalization means if our database design doesn't satisfy some of the normal form test, then we are going to further decompose our database design until it satisfies each of the normal form test. So in the normalization process, we will first check whether it meets first normal form, then second normal form, then third normal form. If they are not specifically satisfied, then we are going to do the normalization. By normalization means a certain table may have to be decomposed until they are satisfying all of this normal form. Okay, now after the normalization, there are a couple of properties. We are going to ensure that the relational schema must maintain those property. So the first property is non-additive join property. This property guarantees that spurious tuple generation problem will not occur with respect to relational schema after the decomposition or normalization. So spurious tuple generation problem is extremely severe, and in any case we do not want to generate any kind of spurious tuple because that can create a severe damage in our application. This is extremely important. So after any kind of normalization means normalization can create a decomposition in our relational schema. So after those decomposition, we'll make sure that will guarantee that there will not be any spurious tuple generation problem. Okay, so this property is extremely important. The second property we want to maintain, that dependency preservation property. We want to ensure that after the decomposition or normalization, the dependency, the functional dependency should be represented in some individual relation. Okay, means that we want to preserve this functional dependency in our decomposed relation. Now that's also important, means desirable but not extremely important like the first one. Okay, sometimes we may have to sacrifice for other factors. So before we talk about first normal form, second normal form and third normal form, we want to talk about definition of key and attributes participating in key. So we have to be sure about definition of superkey and key. We know that a superkey is a set of attributes that identify each of the record uniquely, but key is the minimal superkey. Okay, now if we have more than one key in the relational schema, in that case only one is going to be chosen as a primary key. So each table will have only one primary key, and all other tables we are going to choose that as a secondary key. So an attribute of a relation schema R is known as a prime attribute of R if it is a member of some candidate key of R. Okay, and all other attribute is known as non-prime if they are not a prime attribute, means they are not a member of any candidate key. So let's see in this example, let's say this is our department table. Now in department table, D name or D number both can actually uniquely identify each of the record in department table. Okay, now D name and D number both are candidate key. Okay, it means that they both are minimal superkey, and uniquely, I mean individually, they both can uniquely identify each of the record of this table. So they both are candidate key, but we are going to choose only one of them as a primary key. So we might choose either D name or D number as a primary key. So let's see, we are choosing D number as a primary key. In that case, it will be the primary key, and the another candidate key will be chosen as the another candidate key will be the secondary key. Now the idea is that actually we are not choosing D name as a primary key, but still the value of D name will be still unique. okay, in those record, because dname is going to actually still it has the capability to choose to identify each of the record uniquely. Now in this table, dname is secondary key and dnumber is the primary key. Now any attribute that is part of primary key or secondary key, they are known as prime attribute, and all other attribute that is not part of primary or secondary key, they are known as non-prime attribute. So in our discussion of normal form, these definitions are extremely important, so just make sure that you understand the difference between uh, primary key, secondary key and candidate key, and prime attribute or non-prime attribute.